In my last video, I showed you how to find a side using the sine rule, and I actually showed you where the sine rule came from. So in this video, I'll show you how to find an angle. So remember, we can use trigonometry in triangles that are not right angle, and I showed you where this rule came from using this triangle, and we found that the sine rule was A over sine of the angle that it's opposite, and that's the same as B over the sine of that angle, which is the same as C over the sine of that angle. But we only need to use two sides and they're two opposite angles. So let's have a look at an example. Find the value of theta. Here we want to find this angle to the nearest degree. So I've got theta there. Remember, I only need two parts of the rule. I don't need the three parts because we're only using two sides and they're two opposite angles. So to find an angle, what I'm going to do though before I start substituting in is find the reciprocal of both parts of the equation. In other words, I'm turning them both upside down. So A over sine A equals B over sine B, and I turn them both upside down. So we have sine A over A equals sine B over B. So they're the reciprocals of both sides. So we want to find theta and its opposite, the 8.7. So I'm going to substitute those in for the A and the little a, the side. And then we're going to look at the other side and the other angle. So the 19.2, its opposite, the 117. Remembering I'm putting in the angle up the top and the side down the bottom. So let's substitute those in. Once we substitute those in, don't like the fractions over here. I want to get sine theta by itself. So I'm going to multiply both sides by 8.7. So that 8.7 will eliminate on this side and come over to the numerator on that side, as it's done just there. Now we're finding an angle. So remember, when you're finding an angle, you need to press, if you've got the Casio, the shift button. And what you'll do is you'll get the inverse sine part there on your screen. You've got an open brackets. We want to type all of that in. Just be careful though, you need to make sure you close the brackets there and then close the brackets there at the end, or you'll get a syntax error. So just be careful using your calculator. And when you do so, I've already rounded this one off to 24 degrees. So what you need to do is make sure that you can do that on your calculator and get the correct answer. So that was a fairly straightforward example. This one's going to be a little bit more complicated. So here we have a particular question with several parts in it, and we're going to have a look at how we solve each part. So we've got a boat B leaves port P on a bearing of 105 degrees for 12 nautical miles, and a ship S leaves port P, so that same port, on a bearing of 230 degrees until it is 17 nautical miles from the boat B. So we want to draw this diagram to represent that information. Then we also want to find angle SPB, and then we also want to find angle PSB, and then the bearing of boat B from ship S. So there's a fair bit to do, but what this question does is it steps it out for you. So the first part, let's draw a diagram to represent this information. So the first part of the question is we've got a boat B leaves port P on a bearing of 105 degrees for 12 nautical miles. Well, first of all, we've got our port P, and then from there we want to know where north is. So usually we have north straight up. It makes it easier for us rather than having to turn our page around and think a little bit differently. So there's north, and then we've got the direction of where we've got boat B to, and it's from 105 degrees in a clockwise direction from north. So clockwise direction, 105 degrees. Did I actually measure 105 degrees and draw it to scale? No. It's just a diagram to help us there. And then we can put on our label for B. There's our boat. and we know that it went 12 nautical miles. So that was the first part of it. Now let's look at the second part of it. A ship S leaves the same port on a bearing of 230 degrees until it's 17 nautical miles away from boat B. So I'm just going to put in south there because we should know by now that from north round to south is 180 degrees, and this one's going 230 degrees, so it must be 180 plus another 50 around, must be 230 degrees. So let's put that in. And then we're going to say, well, that went around 230 degrees in a clockwise direction, so let's put that in there too. Remember, that's all the way around, it's not just this part here. And then we can label our S for the ship. And then we know that it's 17 nautical miles apart there, so let's finish off our diagram so that we've got our triangle, and that way we've basically got our information there. I'm just going to get rid of my south line again, and we've just finished our diagram, which was part A. So it looked fairly complicated to start off with, but ends up being fairly easy. So now let's show that angle SPB is 125 degrees. So angle SPB, so that's this angle here between these two rays, so this angle. It's not 230, remember that's 230 degrees all the way around from north and that clockwise. But if that's 230 to there, and we know it's 105 degrees for the bearing of B, then we should be able to work out that angle in there quite easily. So that's the angle we're looking for. So angle SPB, it's that 230 degrees all the way around, and then we're going to subtract the 105 degrees from boat B, and we've just shown that this angle in here is 125 degrees. So let's put it in there. It's in our diagram now, so we don't forget about it. And we've just done part B, and I've just got rid of some extra information there so that our diagram looks a little bit cleaner. What you could do is you could draw a separate diagram within your working so that you have less markings on it and so on, so it doesn't become too messy. Now let's look at part C. Let's find the size of angle PSB to the nearest degree. So angle PSB is this one here. We want to find that angle. So let's mark it, and what we're going to do is we have a look that we've got two sides and the two opposite angles that we have there. So two sides, two angles, so we're going to use the sine rule. So I've just written that up there just as a reminder for you that we use the sine rule for two sides and the two opposite angles that they've got. So remember, we're finding an angle, so I've already done the reciprocal of the sine rule. So when we're finding an angle, sine A over A equals sine B over B. Substituting what we know, so we're finding this angle and it's opposite to 12. And we've got this angle here, 125, and it's opposite to 17. So I've just substituted those straight in. What we can do is get rid of this divide by 12 by multiplying both sides by 12. And then remembering how to use our calculator to find theta. Remembering if you've got the Casio, you're pressing shift sign, and don't forget to close all your brackets. And I've rounded this off already for you. So you might have an extra couple of steps in there, but I'm just doing this so you should be able to practice using your calculator and rounding that off to get 35 degrees. Once you've done that, then let's do the second part, find the bearing. There's a few steps involved there, so I've put my 35 degrees in there to remind me. I've put my north from the ship because that's going to be useful, and we've got these parallel lines. So let's find this angle in here. Remembering it's 360 all the way around. We know that they've already gone 230 degrees round to there. So if we do 360 minus our 230, and we get 130 degrees in that part just there. So let's put that in. There's my working for it. And because these are parallel lines, then we've got co-interior angles, and the co-interior angles add up to 180 degrees. So this angle and this angle should add up to 180. So 180 minus the 130 will give me the 50 degrees for this part in here. So let's put that in the diagram, and we're almost done. So from north, how far do we turn in a clockwise direction before we can face B? Well, it's that 50 degrees we found plus the extra 35. So let's do our working for that and get 85. So this whole part is 85 degrees. And now the bearing of B from S is our 85 degrees. And one thing I haven't put in there is I should put my 0 because bearing should have 3 digits in there. So let's put that in there. So there's our true bearing, 0, 85 degrees. So there's our example with a bearings question. Looks complicated, but ends up being relatively easy once you know how to draw your diagram. So we've answered all of that. What you now need to do is practice, and practice again, and then some further practice. And the more that you do that, the easier it will all become. So I hope you find this video useful and you know how to find a particular angle when you're using the sine rule. And I know I've got side up there. I should change that to angle as well. And thanks for watching.